So just like we had an estimate for population proportion, we can also find an estimate for population mean. So by the sample mean, which we can either call it as X bar, or we can call it as mu hat. Either would work. Using a sample of size n. So if you have a sample, we can find its average. And once we have the average, we can find an estimate for the population mean mu. So key things to note, the point estimate for mu is X bar. The interval estimate with 100 times 1 minus alpha % confidence, just like population proportion, it is for the population mean that is right in the middle, X bar plus E and X bar minus E. Or if you want to use the mu hat notation, mu hat plus E, mu hat minus E. So E is the margin of error. And alpha, just like the estimate, just like the confidence interval for population proportion, alpha here is the level of significance, and it's chosen by the researcher. The level of significance is alpha. The level of confidence is 100 times 1 minus alpha % confidence. So once we find mu hat, finding mu hat is very, very easy. Finding the average simply means you take every observation in the sample, add them, divide by the sample size. So that's the average. We can find that easily using the calculator. So finding a point estimate in this case is easy. Naturally, finding the margin of error in this case is also easy. So we know that the standard error is always the product of, the margin of error is always the product of standard error and the positive critical value. I'll write it as SE for standard error. The positive critical value in this case, I'm going to denote it as T sub 1 minus alpha over 2, comma, df. I would explain those in a second. So SE, T sub 1 minus alpha over 2. The df here is always n minus 1. So df is a term that we use in statistical theory, and that stands for degrees of freedom. And that would end up being n minus 1 after deriving a bunch of equations. Now you may ask, well, what about t? So we use the notation t to indicate that we are going to obtain the critical value from a t distribution. So it is obtained using a student's t distribution. Note in estimating interval for population proportion, the notation for the positive critical value was z sub 1 minus alpha over 2, since z denotes a standard normal distribution. So we use the notation z sub 1 minus alpha over 2 because we use the standard normal distribution. Here, we're using the notation t because we are going to use the student t distribution. The standard error in this case is simply s divided by square root of n, where s is the sample standard deviation. So here, the sample standard deviation is s. So with the TI-AT4 calculator, the critical value, the previous case, to find the critical value with the previous case, we used inverse norm and we plugged in 1 minus alpha over 2, mean 0, standard deviation 1. That gave us z sub 1 minus alpha over 2. Here, we just have to use inverse t, 1 minus alpha over 2. And the key thing here is we have to specify the degrees of freedom, which is n minus 1. And that would give us t sub 1 minus alpha over 2, comma, n minus 1. The direct function that we used with population proportion is 1 prop z interval. Here, it would simply be a t interval. So let's go back to the calculator. So where do we find the inverse t function? So second verse, option number 3 was inverse norm. So option number 4 is inverse t. So all we have to do is select option number 4 instead of option number 3, and we will get inverse t. And we can enter the value 0.975, just like we did with inverse norm, and we can plug in the sample size -1, which is the degrees of freedom. So if the sample size is, say, 32, we simply have to do 32 minus 1, and we would get the positive critical value as 2.039. In contrast, if we did inverse norm and we put 0.975, the critical value is 1.959. So you can see the key difference between inverse t and inverse norm. The t distribution depends on the sample size. So the sample size, if it's very small, we have to account for it. And you may say, well, it's only a small difference, 2.03, 1.95. Who cares? It does make a difference. And, especially in terms of concluding, okay, the average is going to be between these two values, and I'm 95% confident. So you better be 95% sure. And even a slight change here would make a significant change in our conclusion. So that is how we find inverse t. The t interval function can be found in the same location. Start over to tests. If it can go over, it's having issues again. And I believe it's option number 8. It is option number 8. If you select option number 8, we can specify the data, the confidence level, and we can calculate the t interval.